Good afternoon, Algebra 2 students. I thought I would give you a little refresher on this composition of functions, or for those of you, we had several that were absent today in class. Today's Monday, September 28th. So we learned a new concept called composition of functions. So we started out with this. We did, if you have f of x equals x plus 6, and you're asked to find f of 2. This was something that was on the board. So we know from previous experience that what we do in this case with the function notation is take the number that's in parentheses and use it to replace the x. Okay? You might have something like g of x equals the square root of x plus 2, and find g of 4. Okay, so then you would take that 4 that's in parentheses and put it in place of this x. Square root of 4 is 2. 2 plus 2 is 4. Okay, we've done that before. You might have something that looks like this. Let's draw a little line here. And maybe you had h of x equals x squared. And you're asked to find h of 6. And you would take that 6 that's in parentheses, put it in place of x, and get 36. The idea of what we're talking about here is that you take the number that's in parentheses and you plug it in place of the x, and then you simplify. Okay, you've used function notation before where you take the number that's in the parentheses and you plug it in place of the x in your function and you evaluate from there. So then today we moved on to something like this. If f of x equals x plus 5 and g of x equals x minus 5, and your question is going to say this: are f of x and g of x inverse functions? Okay. We're going to use something called composition of functions to verify either yes, these are inverse functions, or no, they're not. So here's what we've got. We're going to find f of g of x. Looks ugly and evil and complicated, but what did we do with those numbers that were in parentheses? And I didn't say that, we can go back. We took the number in parentheses and plugged it in for the x, but now what's in parentheses is not a number, but an entire function. What's in the parentheses is g of x. So we're going to look back here, and what was our function? G of x was x minus 5, right? G of x is x minus 5. I'm going to take that and plug it in place of this x in the function that's labeled f. So replace this x with x minus 5. Then I have this plus 5. Okay, and what happens? Negative 5 plus 5 zeroes out, and we have just x. Okay, we're almost through. Not only are we looking to see if f of g of x cancels everything out but the x, but we also have to see if g of f of x. We're going to go the other way. So now we have f of x inside the parentheses. We're going to take what's inside the parentheses, plug it in place of the x in the other function. So this one, f of x is x plus 5. I'm going to plug that into function g. So I have x plus 5 minus 5. Those cancel. What's left is x. If f of g of x equals x and g of f of x equals x, then yes, these are inverse functions. Okay? So if you take f and plug it into g, and g and plug it into f, and watch to see if everything cancels out except the x. If that happens both ways, then yes, they're inverse functions. Okay? Then if you've been back to class since you were absent, then you have a paper there where we worked some of these. This number 1 said f of x equals 3x plus 2, and g of x equals x minus 2 divided by 3. And the directions say determine if f of x and g of x are inverse functions. We're going to use composition functions to do that. We're going to compose the two functions. If we plug g into f and everything cancels except the x, and we plug f into g and everything cancels except the x, then yes, these are inverses. If either side you have anything left except the x, then they're not inverses. So let's see how this goes. Change colors to kind of keep us a little bit organized. So if I'm going to do f of g of x, that means what's in parentheses? G of x, that's this x minus 2 over 3. I'm going to use that to replace this x. There's the 3. That's this 3. Replace the x with x minus 2 over 3 plus 2. That's this plus 2. Now, when we look at this, what happens to, we have a times 3 and a divide by 3. 3 divided by 3 is 1. So those, they make a 1. We cancel those out. Then we have left x minus 2 plus 2. What happens to a minus 2 and plus 2? Cancels out. And what's left? Just the x. Okay, we're halfway done. Now we have to check g of f of x. Look first at what's in the parentheses. F of x is 3x plus 2. We're going to use that to replace the x in function g. So I have 3x plus 2 minus 2 divided by 3. Now, where can we combine and simplify? The 2's cancel, the 3's cancel, and what's left is x. So yes, these are inverse functions. Because when we plug g into f, everything canceled except the x. When we plug f into g, everything canceled except the x. Okay? Let's move on in your paper. Number 2 is exactly like one that was on the board. You have f of x equals x plus 6, g of x, x minus 6. When I find f of g of x, that means I take what's in parentheses, plug it into the other function. A minus 6 plus 6 cancels, x is left. By the same token, we take g of f of x, which means we'll start inside the parentheses with f of x, plug it in for x in function g. Those cancel. What's left is x. So yes, these are inverses. Okay. This is called composition of functions. You're putting the two functions together. You're going to take g and plug it into f. Take that whole function g, plug it in place of the variable in f. Then you're going to take the whole function f and plug it into the place of the variable in the place of function g. Clear as mud, right? Okay, let's try another one. Here we go. This is number 3 on your paper. You have f of x equals 1/2 x minus 7. G of x equals 2x plus 14. Okay. Now, the question again in the direction says, are these inverse functions? One way to determine that is to use composition of functions. So I'm going to find f of g of x. Start inside the parentheses. What's in the parentheses? G of x. What do we do with what's in the parentheses? We substitute it in for the variable. So I'm going to take this 2x plus 14 and substitute it in for this x. So what do we start with? 1/2. In place of the x is 2x plus 14 minus 7. Okay. Now distribute. Half of 2 is 1. Half of 14 is 7. What do you notice? A plus 7 and a minus 7 cancel out. What's left? Just x. Now we're going to go the other way and find g of f of x. Start with inside the parentheses. F of x is 1/2 x minus 7. We're going to use that to replace the x inside function g. In place of the x, 1/2 x minus 7 plus 14. Distribute. 2 times 1/2 is 1x. 2 times negative 7 is minus 14. Those cancel. What's left is x. So yes, f of x and g of x are inverse functions. Okay. Skip over on your paper a minute and look at number 8. Number 8 has f of x equals 2/3 x minus 3. G of x equals 2/3 x plus 3. Now we need to find f. You'll also see that it's written like this. It can also be written like this, which means exactly the same thing. Start with what's in the parentheses, g of x. Use it to replace the x in the other equation. So I have 2/3. In place of the x, I got 2/3 x plus 3 minus 3. Be careful here. Before you would cancel those 3's, you have to distribute. What happens when I multiply 2/3 times 2/3? Let's go back and do a little fraction multiplication. 2/3 times 2/3. 2 times 2 is 4. 3 times 3 is 9. 4 9ths x plus 3 times 2/3 is 6/3, which is 2 minus 3. Did everything cancel with the x? No, it did not. So because we have numbers left and we didn't cancel everything out but the x, these are not inverses. If they are inverse functions, f of g of x will equal x and g of f of x will equal x. I don't have to do the other way because this one didn't work. It didn't work, it means they're not inverse functions. Okay. What is the inverse of 2/3? 3/2. Okay. So what else we got? Number 4 is a typo. X minus 56 and x plus 5 are not inverses. If I'd have left off the 6 in the 2 periods, then they would have been inverses. Look at number 5. 5 has f of x equals square root of x plus 3. G of x equals x squared plus 3. Again, the directions say determine if f of x and g of x are inverse functions. So I'm going to use composition of functions, and I'm going to find f of g of x. I'm going to take this g of x and use it to replace that variable in function f. Okay, this is what I use to replace the x. This is the rest of that equation. I see 3 plus 3. That doesn't cancel out. Guess what? There's no way that's going to cancel out to just the x because we have that 6 there. These are not inverse functions. If they're inverse functions, f of g of x will equal x, g of f of x. What would happen if we tried the other way around first? If we did g of f of x. So we take this one and plug it in. Okay, this is going to be x plus 3 plus 3. Yeah, that didn't work too well. And you notice that's going to be x plus 6, so that doesn't work either. Okay, that didn't work either. All right, let me see. Look at number 6. F of x equals the square root of x plus 4. G of x equals x minus 4 squared. Determine if f of x and g of x are inverse functions. Let's use composition of functions. So I'm going to take this g of x and plug it in for this x. When I square root a squared, that cancels out that, and I have x minus 4 plus 4. Not finished yet, because we have to check g of f of x. In the parentheses f of x, so I'm going to take this, plug it in place of this x. See where I messed up there? You got square root of x plus 4. That's this takes the place of this x. Then I have a minus 4. Then a parentheses squared. 4's cancel. The square root of x squared, that cancels with that. We have left x. Yes, these are inverses. That leaves you number 7, which is like number 1, and number 9, and number 10. Let's go with number 7. F of x is 3x minus 4. G of x equals x plus 4 over 3. Determine if f of x and g of x are inverse functions. We'll do that by first finding f of g of x. Inside the parentheses is g of x. Replace the x in f. The 3's cancel. 4's cancel. Okay, that went a little fast. We took the g of x. G of x was x plus 4 divided by 3. Use that to replace the x in function f, and everything canceled except the x. Now do the other way, g of f of x. What's in the parentheses? F of x. What is f of x? 3x minus 4. Where are we going to plug it in? In place of this little x right here on top of the fraction. Okay. This is your x, right? And you have plus 4 divided by 3. 4's cancel. 3's cancel. What you have left is x. Are these inverse functions? Yes, they are. Okay, number 9. If you want to take, anytime you want to pause the video and try these, you can, and then you can turn the video back on and check it. F of x equals 5x. G of x equals x divided by 5. Are f of x and g of x inverse functions? I don't know. Let's find out. Composition of functions, f of g of x. What's in the parentheses? G of x. What is g of x? X divided by 5. Where am I going to plug it in? In place of this x. When you multiply these out, you get 5x divided by 5. Those cancel. Are we finished? Not yet. We have to try one more. We have to go g of f of x. So take what's in the parentheses is f of x, plug it into g. So I have 5x divided by 5, which is equal to x. So yes, these are inverses. This is not the only way to tell you can graph them. What do we know about graphs and inverses? If we graph these two, then they'll be reflected over the line y equals x. We could put them in the calculator and get a table and see if all the x's and y's are switched. Or we can use composition of functions. All right, we got one more, number 10. F of x equals 17 divided by x. G of x equals, oh, wait a minute, 17 divided by x. It's the same thing, Mr. Dell. If I do composition of functions, I'm going to take what's in parentheses, and I'm going to put it in place of this x. So I have 17 divided by x. Oh, divided by. That means divided by. Seems like we learned something about dividing fractions as keep, change, flip. And everything cancels but the x. Guess what happens if we did g of f of x? We're going to take this 17 over x and plug it into this 17 over x. And we get exactly the same thing. So yes, these are inverse functions. That's it. Enjoy. Next up is review for inverses test.